Alrighty. Since we have a shortened class tomorrow, I thought it might be a good idea to do a quick video that addresses or reviews the Hardy-Weinberg equation. So you'll see listed, I've got the two forms of the Hardy-Weinberg equation, the first being p squared plus 2pq plus q squared equals 1. And another form of that equation is p plus q to the second power equals 1. Now if we get rid of this to the second power by square rooting both sides, we get p plus q equals 1, which is going to be really useful in a second here. Now I just want to point out that the different parts of this equation stand for different things. So right off the bat, p squared equals all of the dominant homozygous individuals. 2pq is all of the heterozygous individual. Q squared is all the recessive homozygous individuals. P is all the dominant alleles in a population. And Q is all the recessive alleles in a population. And whenever we're doing this, whenever we're using this equation, we always want to show our results as a percentage or as like a decimal point. Alright, so let's do an example problem. We'll see how this works. The first thing we're going to do is we're going to pick a Mendelian trait. So let's go with hitchhiker thumb, and we'll say we have a population of 777 individuals. First thing we want to do is we want to figure out how many individuals exhibit this Mendelian trait, which happens to be recessive. And let's say we go out and we figure it out, and it's 111 folks have hitchhiker thumb. Now we know that hitchhiker thumb is actually recessive, so we're going to represent that by a lowercase h, and we'll do straight thumbs as uppercase h. So right off the bat, again, we know that 111 individuals out of 777 have hitchhiker thumb, and in order to exhibit this particular trait, those individuals have to be homozygous recessive, or little h, little h. Now if I go back, I saw in my equation that the homozygous recessive individuals were represented by q squared. So I've already solved a portion of this equation. All I've got to do is divide 111 by 777. Now if you don't have a calculator with you, that's no big deal. But the answer is 0.14, or about 14%. You can double check if you'd like. I make mistakes. I'm pretty darn good at it. And again, that's going to equal q squared, right up here. Now from there, it's just a matter of manipulating q squared, and I can get almost every other part of this equation. So the first thing I want to get is q. Q again represents the percentage or proportion of recessive alleles in my population. So if q squared is 0.14, then in order to get q, I just have to take the square root of 0.14. So if I take the square root of 0.14, that's going to equal 0.38. So I've now found q squared and I've found q. Relatively easy, relatively straightforward. So let's just clear this up. Whoopsie, I didn't want to do that. Undo. And let's see if we can clear annotations. There we go. So I'll write these in. I'll just pencil these in just to keep things as straightforward as possible. So this is 0.14, and this is 0.38. So now that I've got q squared and I've got q, the next thing I can find is p. And all I've got to do to find p is subtract q from 1. So if I subtract 0.38 from 1, I should get 0.62. Then I can find p squared. All I got to do to find p squared is square 0.62. And if I do that, then I'm going to get 0.38. And then last but not least, I can find 2pq by multiplying 2 times 0.38 times 0.62. And that's going to get me 0.47. Now, if I want to double check how I did, I can add these top three numbers up and they should equal 1. And when I do that, I actually get something like 0.99 because I did some rounding. But that is pretty darn close. And again, when I add these up, I should get 1 here as well. Now, one last thing I'll say is that whenever you're doing the Hardy-Weinberg equation, you always have to start with your recessive homozygous individuals. Remember how I said I had 111 folks with hitchhiker thumbs out of 777? Right? The temptation there is to say, okay, well, could I just start with p squared? Could I say that I know I have 666 individuals who have straight thumbs? Isn't that the same thing as p squared? And the answer is no, because some of those individuals may also be heterozygous. So you never, ever, ever can start with your dominant trait. You've always got to start with your recessive trait. And that, my friends, is the Hardy-Weinberg equation. If you've got questions at all, please leave them in the comments. Thanks.